biography of you with the participants. Dr. Sivakumar Nadarajan, senior member IEEE, received the B.Tech degree in Electrical and Electronics Engineering and M.Tech degree in Electrical Drives and Control from Pondicherry Engineering College, Pondicherry, India, and PhD degree in Electrical Engineering from National University of Singapore. Singapore. He has around 20 years of industrial experience from 2009 to 2024. He was the Electrical Capability Group, Applied Technology Group, Rolls-Royce Singapore Private Limited, Singapore, as a technical manager, electrical equipment health monitoring. Since July 2024, he has been working as an associate professor in the Department of Electrical Engineering at Singapore Institute of Technology, Singapore. He has filed 40 patents in US and Europe, published more than 50 papers in international journals and conferences. His research interests includes condition monitoring, health monitoring, failure prognosis, electrical machine, electric drive, power electronics, and machine modeling. With this, I would like to request our expert, Dr. Siv Kumar Nadarajan sir, to kindly enlighten us with his words of wisdom. Sir, please.
Yeah, thank you, Madam Ashna. Okay, hi, good evening, everyone. Thanks for joining the session. So let me start. My slides, let me share. Okay, I hope you can see my slides. Could one of you confirm you can see my slide?
Yes, sir.
Yes, sir.
Okay, thank you. Okay, so today I'm going to talk about the net zero and electric aircraft overview. So this presentation is basically to give a quick overview of what are the net zero initiatives that the aviation industry has been taking in order to achieve this net zero target. So I've been with the Rolls-Royce for 15 years. So basically, as you all know, Rolls-Royce, the main business for Rolls-Royce is the revenue comes from the aviation industry. So Rolls-Royce is a OEM for delivering the gas turbine engines for the aircraft. So its main business unit is the aerospace business unit. So what are the experience I derived from the working in Rolls-Royce and the initiatives that they have taken in order to meet this net zero target. All these things I put together to give an overview of how the electrification is helping in order the companies or the globally to achieve the net zero initiative in the aerospace industry perspective. Okay, so this is the outline of my presentation. First, I'd like to talk about the net zero, so why it is important, and following that, I would like to talk about what is the global greenhouse emission from aviation industry, and then what are the different market segment and what are the different initiatives that the different market segment is taking in order to meet these net zero targets. Because one solution would not work for all the different types of the market segments in the aviation industry. So each market segment has its own strategy and solutions in order to meet the target. So I wanted to give a quick overview of how it's being done, and then following that, I talk a bit about the electrification, especially talk more about the more electric aircraft and the full electric aircraft initiatives, and some of the then talk a little bit about the electrical machines for converters that are being used or designed for the full electric aircraft, and yeah, and then talk about the challenges because aviation industry is delivering a product or developing something for the aerospace application. It comes with its own slew of challenges. So I want to give a little bit about the insight of what are the challenges that an engineer in the aviation industry or the OEM in the aviation industry delivering a product for aerospace application. Okay, so with that, let's talk about the net zero. So I believe most of you might have heard the keyword the net zero. So this has been a very hot topic in industries now. Um, because it's been there for a while, and in the last 5 years, it's become more popular, and many industries and companies are talking about this. The reason is that this is, I mean, to achieve the net zero, the regulations are coming. The countries, I talk about the countries that taking the measures to achieve the net zero target. So the countries are imposing the strict regulations in order to meet the net zero target. So companies have to adapt their product in order to meet this net zero target. So companies seriously looking into it. On top of that, the big companies, they're taking it as a reputation, because it's if they don't take any measure to be more sustainable, um, and they feel that they are inferior than their competitors. So the company is taking it as it's a measure to show their increase their reputation. So and also the other reason is being that the millennials, that's a kind of a young working force in industries. The surveys was conducted, and the millennials mentioned that okay, if the company is not taking this environment seriously, they are not interested to work in the company. So that's a kind of the alarming message for the industries or companies. So because I mean, the industries or companies, they rely on the young the workforce to build their empire. So if they want to attract the young talents, they have to be think about the environment and try to be more sustainable. So that's the other reason that these companies are looking at the net zero seriously. And also, if you look at a company, we look at it would be a retail investor or the institutional investor. So if the investor is planning to invest in a company, they look at the different parameters to assess the company value. And if you look at that, there's one of the parameters that they evaluate is the ESG, environmental, social, and governance. So this factor brings many. This factor or this parameter is being given a value based on many factors that related to the environment, the governance, and the risk that company taking. All these things they put together and create the number for the ESG. And this ESG score goes high if the company is seriously taking measures to be more sustainable and thinking about the environment and to meet these zero target. So are they taking any measures? So it's also kind of to increase the company to the investor grade. They also that's one of these the net zero is one of the measures that initiatives that they are taking to attract more customer, more investors. So so these are the reasons that the net zero is becoming more popular, and also it is important. And countries are very seriously imposing their regulations and policies in order to achieve that. Okay, so net zero is as if you, I mean, I believe most of you are the engineers in university, or some of you, or maybe the professor, um, kind of training the coaching the young engineers to go and contribute in the industry. So this topic, the net zero, is something that you must know in order to prepare yourself to understand which avenue you can take to build your career in order to be more sustainable in your career. Okay, so that's the reason that I want to spend some time on to explain you or educate you what net zero means. Okay, so net zero, it's basically it's simple to understand. Um, it's, for example, you assume that you have just for an analogy, assume that you have a closed kitchen. Okay, so it has a wall on four sides, and it has only one ventilation hole. So maybe the ventilation, the hole maybe like a kind of assume that it's 20 centimeter diameter. Okay, so now inside the kitchen, it's actually completely enclosed on only the small ventilation for the smoke to go out. Now, if you use the wooden stove to cook, what happened? The wood burned and it created the smoke, right? The amount of smoke that been created by the burning wood is higher, maybe higher, let's say that is higher than the amount of smoke that goes out through the ventilation that you have. So what happened in this scenario? The more the wood you burn, the more smoke is being built inside the kitchen, and eventually filled with smoke, right? So that's the kind of scenario that we are talking about here. So since 1850, we have an industrial revolution took place, and then we started emitting more and more greenhouse the emission, the CO2 into our environment or in our atmosphere. And so it's kind of this building up. So that's what we are seeing here, right? The global, the greenhouse gas emission is keep increasing, and the CO2 removal is not increasing that significant, because this CO2 removal is from the forest that we have, the trees that absorb the CO2, right? That hasn't gone up significantly. It's been reducing, right? The deforestation is happening. So the mechanism that we have to remove the CO2 from the environment is keep reducing. So that's the imbalance is being created now. So we're emitting more CO2 and we don't have enough mechanism to absorb the CO2. So this is the imbalance we have. And if you look at the current scenario, I mean, in the 2024 or 2023, the emission is about 57 gigatons equivalent of CO2. Okay, so this is quite significant. And then if you don't take any action, this emission would be keep increasing. So, so the so the Paris Agreement, which is was signed in 2015 with a concern from many countries oblique or agreed to oblique to the agreement is that by 2050 they want to work together to achieve the balance, like what you see here. The emissions is equivalent to the carbon CO2 removal. So it is something like you do something, or maybe the go back to the kitchen scenario. So you have a stove, the wooden burning wood to cook, and then you are but you have very small ventilation. So the removal of the CO2 from the kitchen is very less, whereas the generating the CO2 from the wood is higher. So how do you do that? I mean, how do you balance it? So by putting, for example, if you put up the exhaust fan on the small ventilation hole that you have, and if you increase the speed of the ventilation fan, then you can suck the smoke at the same rate as it is being generated. So if you do that, you are balancing the emission, the emission and removal is happening at the equal rate. So the environment is cleaner, right? So that's some sort of things that we want to achieve. But again, the challenge is that we are emitting way too much of CO2. We have been doing that, right? But if we all of a sudden we cannot find a way to suck all the CO2 from the atmosphere, right? So because if you do that, with current technology is not possible to do it, and also even if that exists, it could be really expensive. So we need to find a mechanism. I mean, so we need to balance it. So first thing to do is that first we have to reduce our CO2 emission to the level. So you can see that over the year by 2050, we have to reduce the CO2 emission significantly. So once we have the emission has been reduced, and then you can have a mechanism to can build over the period years, we can next 20 years we can build a mechanism to suck the CO2. So it be limitless, and the removal is also easier. So that's the sort of the balance we want to do it. The next question is why we have to do it. I mean, what the net zero really means is that the net zero, if you achieve this net zero, that's emission is equal to removal. If you achieve this by 2050, we would be able to limit the global warming to 1.5 degrees Celsius. Okay, so from the where we started the industrial revolution, right? From there, since now, it's already been like a 1.45 degrees Celsius increase. So if you don't take any measure, it would increase higher, like it might go to 2 degrees Celsius in 20 years, and then maybe in another 10 years, and maybe like 3 degree, 4 degree. So it will cause a catastrophic effect, right? Because I mean, you know about the global warming and that's impact. I don't need to talk about that one. So the net zero initiative is to achieve the target of limiting this global warming to 1.5 degrees Celsius no later than 2050. So that is the net zero means actually. So we take initiatives to make the balancing, the carbon, the emission is equal to the removal by 2050. By doing that, we can limit the global warming by the increasing temperature by 1.5 degrees Celsius. So that's the net zero means actually. So again, going back to the kitchen scenario. So how we can do that, right? So I'd say that, okay, we can put a ventilation fan to suck and pump the air out. So, but if the smoke is too high, the ventilation fan will not uh, be more efficient. So in that case, we have to go for some other way of cooking, right? For example, if I remove the wooden stove with the induction stove, the induction stove doesn't emit any smoke, and the smoke comes from only what you cooked, right? And in that case, it's and even a small ventilation fan that I can put to suck the air out. So that's the sort of the analogy that you can think of to see that if I reduce my emission and over the years, and also it's easier for me to remove the carbon from the atmosphere. So that's what the balance that we want to achieve, right? I'll talk more about. You may be wondering how to remove what is the mechanism we currently have to remove the CO2. I touched a little bit on that in this slide. Okay. Okay, so I talk about the net zero, what it means actually. The net zero goal, as I mentioned, the primary goal is to limit the global warming to well below 2 degrees Celsius with the more ambitious target of limit the increase to 1.5 degrees Celsius. Okay, so that's the global, that is the primary goal that we want to, I mean, net zero goal means. So when it was, I mean, agreed, like, it was agreed in 2015 in they call it as a Paris Agreement. It's an international treaty adapted on December 12th of the 2015. It's happened in the 21st conference of the United Nations Framework Convention on Climate Change, the UNFCCC. Is this a conference that it happened? And since then, it's been like more and more countries are willing to adopt this I mean, adapt their policies in order to achieve this target. Okay, so I said that. Okay, so this is what the numbers that you can just to show you that. Okay, 2016, the global CO2 emission was like 52 gigaton equivalent of CO2, and 2030 it would go up by. I mean, I think I hear that even the 2024 itself we have around 57 gigatons, so it's much higher. We already have. So if you don't take any measure, by 2030, it will be even higher than this, 58, more than 58 gigatons equivalent of CO2. So we have, what we need to do is we have to, according to if you want to achieve the net zero by 2050, that's middle of the century, we're supposed to emit only 25 to 30 gigaton by 2030. But you can see that there's a big difference, right? At least we have to reduce the emission by half in next 5 years. So if we do that, then only we would be able to. Hello, by the way, can you hear me? Well, is my connection stable? Yes, sir. Yeah. Okay, because I'm hearing some warning sound, so I thought that my connection is poor. Okay. Yeah. So that's so we have to take. I mean, everybody has to take the serious steps to reduce the CO2 emission significantly, so that we can achieve the net zero target. Okay, so what are the mechanisms that we currently have in order to reduce the global CO2, the greenhouse? Okay, so the afforestation. So this is a very well known, because if we create a forest, it will be it suck the CO2. So that's a well known approach. And the build with biomass, the building with biomass. So it's kind of we're going with a very conventional way of building house, like use the wood, or the hay stalk, or the organic materials to build the house. So by doing that, the wood, the organic material, it's for the carbon. So if you're building a house by using the kind of the modern method, right? We are burning. For to we make the brick, we burn. We burn. We make brick of the clay, and then we cook the clay to make it as a brick, right? So we are burning, burning the we are burning something. It could be a fuel, or it could be the hay stock to create. So that time it is CO2. Whereas if you just build the house using this organic material as it is, we are basically keeping the carbon, and it's not been in the building itself. We're not releasing it. So that's one way. And biochar is basically, it's kind of burning the biomass. That's kind of the plants tree at a very low oxygen level. It's called pyrolysis. This create a biochar, which is has so many application. It basically can be used to enrich the soil. It can be used as a fertilizer. It can be used as a catalyzer. It has many applications. So this is one way of preventing the trees or plants burning, and we can just the way of creating the char that can be used. And the direct air capture. This is the again the emerging technology, and this being this is this has many rationale for doing the direct air capture. The direct air capture is that we have a big fans to suck the atmosphere air, and then there will be a membrane that filter the carbon in the air, and then we use some solvent to dissolve the carbon, and the dissolved carbon is being stored. Um, Sometimes it's stored and use it to make the fuel again, because the captured carbon is used mixed with the hydrogen to create the carbohydrogen chain, hydrocarbon chain to make a fuel. That's the bioenergy with the carbon capture and storage. So this is the other technique. You can see that these are all quite expensive. And then the habitat restoration is the other approach, like create an ecosystem that recreate the ecosystem that help us to provide the clean air, clean water, and the natural pollination. That's kind of increasing the natural way of making the things better. And soil carbon sequencer is again grow the plants or tree that hold the carbon in the soil, that capture the carbon and put it in the soil, and enhance the weathering. Weathering is something like it's a process of the natural, basically accelerate the natural process of um, the carbonate and silicon, and the carbonate is absorbing the CO2 from the environment. So that's kind of accelerate the natural process. So these are different techniques over there to capture the carbon. So these are all expensive. Some of them are expensive, really expensive. So we can do it. It's not possible to suck all the carbon being emitted, like a 58, probably that by 2030, if we emit 58 gigatons equivalent of carbon, we cannot have this technology to suck all the carbon. So we have to bring the emission down so that we can bring these techniques to remove the carbon, so to make the carbon neutral. Okay, so this is just a chart to show that so where we are from the pre-industrial revolution to now on the global the warming, right? So this annual temperature anomaly, we can see that from 1860 it is above, the anomaly is it's around 0, but and it's been increasing, and last year it was like 14.5, 1.45. So that's the anomaly that we are seeing. That's increasing temperature. So if you're not taking any measure, it will be go higher, and then it leads to it trigger many other disasters, right? So that's the reason it's net zero is important. Okay, so we talked enough about the net zero, and so the countries are really taking it seriously. Yes, as of 2024. With about more than 100 countries that's responsible for the 82% of global greenhouse gas emission. That's a main contributor of the greenhouse gas emission. They agreed to adopt the net zero initiatives. So they adopt the net zero initiative by enforcing law or by changing the policy document. or the making the long-term strategy. Okay, so these are some of the status of what the countries are doing. For example, since we are in the Asian region, so if you look at the countries, our neighboring countries, you can say the Bhutan, they cover the domestic sector, all sectors. They say that okay, they have policies, they implement the policy document to say that they have to take the net zero initiative, and they claim that they already net zero, which means that the emission from the domestic sectors is if they have mechanism to absorb it. Okay, so maybe they have more forests, or there maybe there's some other mechanism that we need to learn. Okay, how they're doing it. And Singapore again, so very proactive in this one. So they claim that by second half of the 21st century, they want to go net zero. Okay, so again, they excluded the aviation shipping, but for the other sector, they want to go net zero by the middle of the second half of this 21st century. So the different companies, the countries are implementing the policies to achieve the net zero target. So globally, where we are on the achieving the net zero target, right? So this is interesting actually. So in 2015, the Paris Agreement has been signed. So since then, globally, I mean, countries, companies, they want to make the policies or changing the strategy of the product in order to achieve this target. So we are somewhere in the middle, because I mean we have looked at another 25 years, I would say, to achieve the net zero, and to assess the net zero progress, to see how well we are doing, by whether we will be able to achieve the target by 2030 or 2050. They have 42 indicators to assess the progress. So these are the 42 indicators. Out of the 42 indicators as of 2023, only one indicator shows that it's in the right direction. The progress is in the right direction, which is the sale of electric cars. Whereas the some of these in right direction but off track, and some of them, most of them, are in the right direction but well off the track. So it's very far behind the achieving the net zero by 2050. And some of them are going in wrong direction. For example, the global steel production. So the global steel production is supposed to reduce the intensity of the carbon emission, but actually they are emitting more emissions. So this is kind of a U-turn it's not going in the right direction, kind of reducing the emission. It's kind of increasing the emission rather than reducing. So these are in the wrong direction. So these are the status now. So that's one of the main reasons that the companies are the countries are imposing the strict laws and the policies. So when the countries impose the laws and policies, it eventually is translated to the economical reformation, and then translate that has an impact or force the companies to change their product, to take the initiative in order to reduce the CO2 emission, either what their product emits or the CO2 emission that they have on their production or manufacturing a product. Okay, so with that note, let's look at who is contributing, and what are the contributions, what are the different industries that contribute the CO2 the level of CO2 emission. So as of 2023, the recorded emission is about 57.1 gigaton equivalent of CO2 emission. So the energy sector, which is the power sector, which is the key contributor, like a 26% of the emission from the power sector, and then the next big is the transportation sector. The transportation sector emits about 15% of the global CO2 emission, and then the rest of the other sectors. So since I'm talking about aviation, so let's look at the transportation industry. So transportation industry, you can see the road transport, the sea transport, and the air transport. The aviation is part of the air transport. So aviation makes about the 2% of the global CO2 emission. So out of the 11%, sorry, 15% from the transportation industry, the 2% of it is coming from the aviation industry, which is significant. It may not look significant, but if you look at the way the air transportation is growing, so it is that it's growing at a 4.3% per annum over the next 20 years. So that's the kind of the prediction we have. So this is a significant growth in the air transportation. It is estimated that about 10 billion passengers will be traveling in a year by 2050. So this is a significant increase in volume of the passengers being travel in the using the air transport. So there will be more emissions that may come. So maybe over the years, the emission may be more than the 2% of the global CO2. Okay, so definitely this industry requires the measures to meet the net zero target. So let's look at what are the levers that the aviation industry has in order to reduce the CO2 emission, right? So before to look at what are the levers they have in order to reduce the CO2 emission to meet the net zero target, or assisting to meet the net zero target, is we need to, so before that we need to look at what are the different market segment in the aviation. So these are the 5 categories or the segments in the aviation. So actually it's not a strict the segment market segment. Some use the 4 market segments, some 5. So here I'm showing the one with the 5 market segments. So it's based on the size of the flight. So urban air mobility, that's a UAM, which includes the vertical takeoff and landing vehicles and the air taxi. It's a very short range flight with a 4 or 6 passengers aircraft. Commuter aircraft is the slightly bigger. It's with a 9 to 50 seated aircraft. It travels more than more than 100 kilometers. And then regional, 50 to 100 seated aircraft, and a medium haul, 200 around 200 seated aircraft, and then long haul is more than 250 seated aircraft. Okay, so these are different categories of the segments of the aircraft market, and as the size of the aircraft used in these market segments are different, and the power requirements are different. So one strategy would not be, or one initiative of the CO2 emission would not work for all. So that's why we need to look at different levers to reduce the CO2 emission from different market segments. Okay, so let's look at what are the levers that the aviation industry has in order to reduce the global the greenhouse gas emission from the industry to achieve the net zero. The first is improving with technology. Okay, so the aviation industry is being there for around 100 years, and they have been improving and growing, but now it's just we want to achieve the CO2 net zero target. We need to take some step improvement in the measures or the way it's been looking at. So the low hanging fruit is the improve the efficiency of the fuel efficiency. The fuel efficiency can be increased because the fuel consumption is based on the payload, right? So what is the heavy, how heavy the aircraft is. So by looking at the avenues in order to reduce the aircraft weight and the power consumptions in the aircraft, so we would be able to increase the fuel efficiency of the aircraft, or so by reducing this, basically by reducing size, we can increase the fuel efficiency. So that's kind of the avenue that the kind of the existing industry, the OEMs are looking at it in order to improve the efficiency, and then adapting the next generation technologies like a battery powered propeller, hydrogen fuel cell, or making the innovative aircraft design. So these are some of the other measures that is taken, and that's in order to increase the efficiency, performance, so that it can be the energy consumption will reduce, or it will enable us to use the clean fuel to fly the aircraft. So this is using the innovation with the technology. That's the one lever that they use. The second one is the improvements in operation and infrastructure, which is more of looking at the fleet level. Okay, so how the airlines can operate the aircraft more effectively, how we can increase the utilization of the aircraft, how they can increase uh, the the airline load factor improvement. So, for example, the airlines can work together to share their aircraft, so to increase the utilization of the aircraft. So this is some of the strategies that being taken by the different airlines coming together and adapting some AI and the predictive maintenance um, uh, and some other the kind of the forecasting techniques. All these things are put together to see how well we can optimize the operation. So that's the other lever that they are looking at to reduce the CO2 emission from the aviation industry. The other one is sustainable aviation fuel. The sustainable aviation fuel is a topic by itself. Okay, so it is the um, for a long haul or a medium haul aircraft. That's a big aircraft. Bringing the electrification may bring a slight marginal benefit, but it will not be able to bring significant benefit because the technology is not there. The battery technology is not there. Or even the motor technology, or those things, or the power density that we are looking at on the motor or the battery is not there to completely electrify the long haul or medium haul aircraft. So the one of the avenue to look at it is, okay, how I can change my fuel. Currently, kerosene is used to power the aircraft. So can I go for any alternative fuel? So that which will emit less emission or zero emission. Right? So that's the kind of this. I mean, that's what the sustainable aviation fuel is talking about. It's either use the biomass to create the fuel, or it use the synthetic approach, like do the electrolysis, break down the water into hydrogen and the oxygen, and then capture the carbon from the atmosphere. So take the carbon from the atmosphere, take the oxygen and the hydrogen from the electrolysis, put together, create a carbon hydrogen chain to create a fuel. That's a synthetic fuel that can be created and used in the aircraft, which is more cleaner. I mean, may not be cleaner, but it is like they are not we are not pumping the crude oil from the ground and then burning and then emitting the carbon. It's kind of something like we're capturing the carbon, creating the fuel, and emitting the carbon again in the atmosphere. So it is kind of creating the neutralize the carbon emission. So that's the kind of I mean, it's the approach that's been taken in the sustainable aviation fuel. So that's very interesting topic. If you have time, you can read by yourself. And then the out of sector carbon reduction market based measure. So this is like the aviation industry, it's go and invest on the other technology like carbon capture, direct air capture technology. That will is kind of buying the carbon credit. Okay, so they go and invest or buy the companies which capture the carbon. So whatever the carbon being emitted by their product, and then they use this out of sector carbon reduction technology to suck the carbon from the environment, and then they store it or use it in other purpose. So this is the other way of reducing the overall emission. So these are the different levers they have. Okay, so now let's look at the innovation with technology. So as I mentioned that the increasing the aviation, increasing the fuel efficiency is the key. I mean, one way of reduce the CO2 emission, because if you increase the efficiency of the gas turbine engine, which you see here, by 1%, each aircraft would save about $100,000 or $200,000 per year. So if airlines has 10 or 20 aircraft, the savings could be in millions. So this, I mean, the savings on the fuel will be in millions, and then you can think about the CO2 emission savings from that fuel, right? So that's companies or invest, I mean, putting the more effort to make the next generation engines more efficient. Okay, so I mean, but and also the other approach they're taking is the composite material, because as I mentioned, if we reduce the aircraft weight, the overall fuel consumption would reduce. So instead of using the conventional material, can we go with some composite material which is lighter and more rugged? So this is again that a lot of material research is going on to see how we can reduce that. So that's other measure the industry is taking to reduce the overall weight of the aircraft. And the other approach is the electrification. So electrification, I talk about that in the later slides. So electrification helps us to reduce the weight of the aircraft, because it could help us to remove the existing hydraulic and pneumatic system in the aircraft. So currently, about 150 billion global investment is going into the research to increase the overall efficiency or fuel efficiency of the existing aircraft, or the next version of the conventional aircraft, I would say. Um, so um, yeah, so this will help us to achieve implement all the measures, that the electrification, composite material to reduce the weight, increase the efficiency of the engine. If you do all these things,
कंप्लीट छूट गया है तो
we will be able to see
एक
like
बार से देखो तो
some improvement in efficiency by 2030. That is that the target is. So that would translate it would be like predicted reduction in the global aviation emission by 40%. Okay, so that's the innovation with technology. Now let's talk about electrical technology. Okay, so this is an interesting, you can see that. So for example, okay, if you're not taking, okay, this is where we are now, like 2025. This is the emission from the aviation industry. It's about like around 1.25 gigaton CO2 equivalent emission. So if you don't take any measure, it will be like by 2050, the emission would maybe double, right? And we may see some reduction if you pursue the natural improvement that we can achieve on by the OEM, like using a lightweight material, or using the energy efficient engines, right? But this is still significant. But if you want to achieve the net zero emission in the aviation industry, this has to be far lower, so that we can bring some carbon capture technology to nullify the emission, right? So this is not possible if you don't take any measure. So whereas if you take some measure, we would be able to achieve that. So you can see that in this graph, the gray line is that if you take various measures, the overall emission will be only 4%, like maybe less than 0.2 gigaton, and then we can have a carbon capture mechanism to capture that. So nullify the emission with the carbon capture. And these are the measures that could help us to achieve that the net zero by 2050. So let's look at what are they. The 20% is the continuous historical fuel efficiency improvement through the improvement in the engine efficiency, and then an additional fuel efficiency improvement could be seen by adapting some technology like electrification, or maybe the lightweight material and so on. But what interesting is that the red color and the orange color curve here. So the battery, the electrical propulsion using the battery technology, and the electrical propulsion using the hydrogen as a fuel, or using the hydrogen fuel cell, we would be able to achieve like 28% of the CO2 reduction by 2050. And then the power to liquid, this is the can help us to achieve 29%. What it means, the power to liquid is what I mentioned earlier. Like we can capture the carbon from the atmosphere. We can have a very big fans that suck the air in the atmosphere, and then it can filter out the carbon, and then we can use the carbon to create the fuel by taking the hydrogen that comes from the hydrolyzing the water, breaking down the water into hydrogen and oxygen, and then combining the hydrogen carbon. We can make the fuel. Okay. This process of creating the fuel, it is a very energy hungry process because hydrolysis takes a lot of energy, capturing carbon takes a lot of energy. So if you have a lot of renewable energy power generation, so they can use the renewable power, which is a clean energy, to do the hydrolysis and to do the carbon capture, and then to do the Fischer-Tropsch approach to create this power to liquid. That's the kind of synthetic fuel. So if we can do that, we can again say reduce the 29% of the CO2 emission. So all these things, the battery propulsion or a hydrogen fuel cell propulsion, or to generate the power to liquid, that's a synthetic fuel, we need electricity. So what I would like to conclude here is that the electrical engineering is going to play crucial role in the aviation industry to reduce more than 55% of the CO2 emission by 2015. So I believe most of you in this call are the electrical engineers. So each and every electrical engineer, you have crucial role or have opportunity to play a role in achieving the CO2 emission to achieve the net zero. Because this is the aviation industry is just one example that you can see that, okay, 55% of emission reduction that relies on the, actually it's more than 55, because if you look at the efficiency, this 13%, it could also be contributed by the electrification. So more than, I would say, about 60% of this, the reduction emission can be enabled by the electrical technology. This is just for aviation industry. If you look at other industries like marine or the land-based transport, the role that electrical engineer has to play in order to bring the CO2 emissions even higher. Okay, so please be proud to be an electrical engineer in this era. Okay, now let's look at the electrification. I told you that, okay, these are different market segment, how the electrical, the aircraft market segment has been classified, and different strategy has to be adapted because the technology, the electrical technology, the battery technology is not there yet to make full electrify the long haul or medium haul flight. So for this, the net zero initiative for this medium and long haul flight is mainly the SAF till 2050. That's a sustainable aviation fuel. Whereas for the commuter or regional or short haul, the electrical propulsion that's using the battery technology, or the propulsion using the hydrogen fuel cell that they generate electricity, and then we use the electrical propulsion for the use for propulsion. That's will be playing that will be from 2050 onwards. We may see the commuter aircraft with electrical propulsions using the battery or the hydrogen fuel, and then by 2030 the regional market will be electrified using the battery or fuel cell, and then long haul will be, maybe it will not use the hydrogen fuel cell, but it may use the hydrogen as a fuel. Okay, so electrification may, but again, creating the hydrogen, extracting the hydrogen is again the energy hungry process. So renewable has to play a crucial role here. So electrical engineering is very important here as well. So now let's look at the aircraft electrification. So what are how the electrification helps the aircraft to reduce the CO2 emission? So there are three categories the way of electrifying the aircraft. One is that the more electric aircraft, which is that this more electric aircraft which uses the conventional aircraft engine to fly the aircraft, but some of the key components, key systems of the aircraft which currently uses the hydraulic or pneumatic, that could be replaced with the electrical motor or power converter, right? Electrical drives basically. So that's the kind of, for example, if you take example, the hydraulic system is currently being used to control the wings. You can see that if you're in the aircraft, you can see that the actuator is used to lift the wings during the landing and takeoff, and again the the gears, the landing gears. And then there's the gas turbine engine has compressor blades. These compressor blades or turbine blades, the angle of impact has to be adjusted in order to adjust the power. So for that, they use the hydraulic actuators to change the vanes in the compressor and turbines. So that is using the hydraulic, but we can replace that with the electrical drives. So that's the kind of the electrical mode. So the electrifying certain systems in the aircraft that provide the weight savings as well as the energy efficiency. It will be increased. So that is the part of the more electric aircraft focus. The hybrid electric aircraft, it's very well known. It's very similar to the hybrid electric vehicle, where we can use both the power of the engine as well as the motor powered by the battery to assist the propulsion. And a fully electric aircraft, it's rely fully on the power, the storage power in the aircraft to drive the motors, and the purely electrical motor is used for the propulsion. Okay, so more electric aircraft, how it is done. So this is the how currently the conventional aircraft looks like, or the current aircraft looks like. So the red color thing that you see there, that's flowing across the around the aircraft, which is the hydraulic system. So hydraulic system is used in various places. They're used for the actuators mainly, and also for the cooling. They use the hydraulic sometimes, the fuels in the hydraulic system. And the blue color one that you see, that's a pneumatic system. That's purely based on the air. So, for example, in the automotive, to start an engine, we use electrical motor, right, to start the engine. But in the aircraft, to start the gas turbine engine that you see here, they use pneumatic. What it means that they have a small engine on the tail of the aircraft. So they start that engine first, and that engine sucks the air, and then that air is pushed through this pneumatic channel that the pipe basically, and this pipe bring the air to the blades in the main engine. So, and then the blade starts rotating, and that's how the pressure is built in the combustion chamber, and then they ignite. That's how they start the aircraft, which is what currently being doing. And the pneumatic, that providing the channel, having the auxiliary, the engine at the back to create that the air pressure. So all these things adds to the weight. So for example, if I replace, currently a lot of research has been going on in order to replace this pneumatic system with the electric starter, which is more efficient. So similarly, the de-icing, right? To de-icing system, like if you want the aircraft to in the winter season, the aircraft has to be de-iced before takeoff. So for that, again, the hot air from the engine is blown through the pipes through the surface of the aircraft to make it warm, so that the ice could melt. Instead of doing that, maybe you can use electric heaters, right? So that will be more efficient. So these are some of the things can be is happening currently. There's a lot of research has been going on in order to make these things happen. So that would increase the efficiency of the aircraft, reduce the weight. So that's the kind of focus of the more electric aircraft, concept. And then the hybrid electric propulsion is, again, I don't want to talk much about it because you know very well. In the series, it's two categories. One is the serial hybrid and the parallel hybrid. The serial hybrid, the motor is the one driving the aircraft. So serial hybrid, the engine is used to generate electricity, and then the generated electricity is then used to power the electric aircraft. And if you need more power, then the battery will also supply the power, right? And parallel hybrid, it's both the motor and the engine are coupled together. So these both assist to provide the propulsion power. Okay, so the hybrid electric system is reduce the fuel consumption up to 5% compared to the standard flight. And this could be higher. You can go as high as 10% for the helicopter or generator lighter than the fixed wing aircraft. Okay, so and this is just to show that some of the activities that I mean the industries, as I mentioned, the aviation industry is looking into the uh, I mean we're taking various measures to achieve the net zero by 2050. 2050. So the companies, they come together like Airbus, which is the airframer, and the Rolls-Royce, which is the OEM, and Siemens is also an OEM. They came together and they had a project called the EFANX. So the idea of this project is that they're kind of creating the hybrid system. So because um, I mean each company has its own strength, right? Their own strength. For example, Rolls-Royce, they have they have the small engine. They have the small engine, and they can make the engines even lighter for the design for a small application. So they develop the engine just to drive the generator to generate electricity. So they contributed on the generator. They contributed on the engine that's integrated with the to make our generator, and they build a power converter. And then the Siemens, they basically replace one of the gas turbine engine with the motor with the fan. As you know, the Siemens is an electrical company. I mean, they're strong in electrical. So they come with the propulsion motor and the power converter. And then Airbus provided the energy storage system and the user interface system and supervisory system. So they put all together, and then they demonstrated they developed the demonstrator to demonstrate the hybrid electric system. So this demonstration happened like 2-3 years back. Yeah, so that's the companies came together and working to demonstrate the concepts. Okay, so full electric aircraft, which is a short range aircraft, and with the passengers is like a number of passengers very limited, like 4 to 6 or 10 passengers, and it's categorized as urban air mobility. And this is the market segment is predicted to be booming very fast, because the prediction says that by 2050, that's in 25 years, two-thirds of the population, two-thirds of the world population will live in cities. That means that around 66% of the people will live in city. So now, so we can see that how the cities are crowded. Okay, the roads are being expanded and it's being stretched, and it's being the kind of packed with the vehicles during the peak hours. So if your population is getting increased in the cities, so the land transport is not it's already stretched, so may not be able to take may not be able to the commuting may be the affected. So they predicted that the flying taxi or air taxi is the kind of solution for it. So the aviation industry predicted that, okay, maybe in the next 10 or 20 years, or maybe next 5 years, we may see that this air taxi is flying. So this is a different ball game by itself, because it's purely based on the electric propulsion. So then the energy storage system and the electric propulsion. So this is the currently being the focus in many companies, and many startups have been working on the developing and building and qualifying and certifying the full electric aircraft. So what are the primary component or the key components in the full electric aircraft? Is the electrical motor, or electrical machines, power converter, and battery, right? So electrical machines, or and it's already has a very good efficiency, which has over 95% efficient, which is more efficient than the combustion engine, which is around 50%. But the challenge is that if you talk about the aircraft, the weight and space constraint is there. Right? Anything that goes to the aircraft should be lightweight and should be smaller in form factor. So the research for the building the electrical machine for aircraft is the research is primarily focusing on how we can make the electric machines more compact, how to increase the power to weight ratio. So power to weight ratio that they're targeting is, I mean, should be more than 13 kilowatt per kilogram. The state-of-art motors can achieve the power density about 8 to 10 kilowatt. So the pushing the boundary, reducing the weight of the motor and increasing the power rating. So that's where a lot of research is going on, the materials, the machine configurations, um, and integrating the machine and power converter together in order to reduce the overall drive the weight. So there's a lot of research has been going on, and then some of the companies have successfully demonstrated the high power density motors as well. Okay, so we know that the electrical machine, the radial flux machine, is what widely being used in industries and many applications. And for the aerospace industry, the axial flux and the transfer flux machines are becoming more popular. Because the axial flux machine has advantage of increased power density and efficiency, especially well suited for the aerospace application. Because the axial flux machine, you can see that this is stacked, the rotor and the stator are stacked together. So if you want to increase the power, they can stack the stator and rotor, increase that. So it's kind of modular mission sort of thing. Instead of going with the circular, the conventional radial flux machine with the fixed stator and the fixed rotor. So this axial flux machine provides a flexibility to increase the power by stacking the stator and magnet layers, right? So the companies, the OEMs, the aircraft OEM manufacturers, OEMs, they already built the commercial axial flux missions for the aerospace application. And companies like Rolls-Royce, they have they looked at the different configuration mission, which is the transfer flux mission, because they want to utilize the three-dimensional magnetic field to enable the high torque density. Because the transfer flux mission, which has both the radial as well as the axial fluxes, so they utilize both the radial and axial flux to increase the power density. And since these machines are to be lighter weight, the cooling has to be simple. It is air cooled. It is the weight density, the power density can be increased. If it is if it is a liquid cool, when calculating the power density, they have to consider the weight of the cooling, the cooling system as well. So if the machines is more, is it kind of designed in such a way that it can be easily cooled, use the air cooling, it will be help to reduce the weight and increase the power density. So in this transfer flux machine allows since the windings are not inside the stator, it is kind of the stacked on some of them are stacked on the surface. It is easy to cool. So that's one of the reasons they have gone for this mission. So this is the transfer flux missions that Rolls-Royce designed. This is in the prototype stage. So this basically produces a three-dimensional magnetic field that, as you can see here. So this is the prototype they have, and then the commercial product would look something like this. So you can see the size of the mission, which is quite compact, and it is some cases it will be integrated with the power converter. Actually, this is the power converter that you can see. Okay, and then the other company like Magnets, they have designed and developed the axial flux machine, which you can see that axial flux machine, it is the stator and rotor are stacked together. So the overall width of the machine is much lesser than compared to the radial flux machine. So the advantage of this is if you have the kind of eVTOL sort of application, the vertical takeoff, right? So this machine is easy to integrate. So because of this structure, it is easy to install the fan, and then they can. So it is kind of more convenient and reduce the drag. And the power converter is again is crucial for the aerospace industry. The power converter has, I mean, if you look at the electrical drives, the power converter, the machines are a bit rugged. Even if we have a fault, it can still run for some time. But when it comes to the power converter, it is sort of weak link in the electrical drive, electrical system. So if the power converter, the power device fails, the converter may not be useful. May not be useful to power the motor because the voltage may become unbalanced. So it's not in favor of driving powering the motor. So a lot of research and went on selecting the suitable device for the power converter for the aerospace application. Currently, the silicon carbide technology has been matured quite significantly. So the silicon carbide is currently being used in some of the prototype being designed by Rolls-Royce and the other companies. So actually, the challenge is that the power device, when it is at a high altitude, it exposed to some of the cosmic radiation. That's some of the concerns that the industry has. So the reliability that the manufacturer code for the device is mainly based on the land-based application. If they need to be used in the aerospace application, the component has to be derated in order to use it. So some of the failure modes of these components are unknown because it's not been the power converters are not being used widely in the high altitude for the high switching frequency application, because some of these missions, the switching frequency is will be in hundred of kilohertz, and then the fundamental frequency would be in kilohertz. Okay, fundamentally it's still in kilohertz, and the switching frequency may be in range of the 30 to 100 kilohertz. So the high switching frequency, how these devices behave at the high altitude, these are some of the things that are not known, and many research and experiments are going on to understand the physics of failure of the power converters. So that's one of the reasons that the power converters, I mean, industries are taking the multi-lane approach. For example, you can see this is a one machine, basically is to drive the propeller, but you can see that they have about 4 lanes, I mean 4 power converters to drive the electrical machine. So even if one power converter failed, the other 3 power converters that drives the electrical the propulsion motor. So that's sort of the approach that industry is taking. This is the prototype which Rolls-Royce currently being developing. So yeah, the picture is not very clear, but it says that you can see the fundamental frequency is 2.5 kilohertz, and the efficiency is 99%, and the power is 100 to 200 kilowatt, and with the voltage it can go from 500 to 900 watts. Okay, so and then the battery technology, it's again, as most of you may aware that the battery technology, the current power density that we have, it's maybe suitable for the air taxi application, but still it's not that kind of again, when it comes to the cost, it may be suitable for the air taxi, but it's not economical to operate. That's a kind of some conclusion that made by some of the aircraft airframer, that they were looking to develop the electric taxis, the air taxis have concluded. So for UAM applications, the urban air mobility, like air taxi application, the current density maybe is sufficient. But if you want to electrify the regional passenger aircraft that fly like 100 kilometers with the more than 10 passengers, that may not be possible with the current battery technology. It may be possible only if the battery technology is providing the power density of energy density of 500 watt-hour per kilogram. But may not be available before 2030. So that's one of the reasons that the industry is now looking at the fuel cell as an option for the electrical propulsion rather than the battery technology. Okay, so we have another 15 minutes or 16 minutes. Let me quickly talk about the challenges, then I give some time for the Q&A. So the challenges is that when it comes to the aviation industry, it's again, it has if you want to fly the aircraft in Europe or America, or even anywhere, it has to be approved by the aviation authorities. So the Federal Aviation Administration, FAA, and EASA, these are the 2 key aviation authorities. They provide the guidelines or the process to approve the aircraft to that which can fly for the commercial application. Okay, so currently they have the set of the standards, the guidelines that the standards basically provide the guidelines for the aircraft OEMs to follow in order to develop their product, and then they qualify and certify their product. So currently, since the industry, as I mentioned, that the aviation industry predicted that more than 2/3 of the population will be leaving the city, and then air taxi is something the industry would boom up. So this industry, the ASO, the aviation administration and the federations, they are coming up with they're upgrading this the FAA Part 23, CS23, CS23A, and the FAA Part 23 is for the guideline for the safety and reliability of the small aircraft. They call it as general aviation market, the small aircraft market. So they have come up with they want the standards for the in 2017 for the small aircraft. So which allow the larger classes of general aviation aircraft to legally fly. Legally fly with the non-traditional engine types. The traditional engine types are basically the gas turbine engines or propeller-based engines, right? So the airworthiness authorities also have to find a way to certify the novel aircraft architecture. Because of about 50 years, the commercial aircraft has not deviated from the gas turbine powered aircraft. So this is new to the airworthiness team. So what are the safety precautions or the reliability? What are standards that they need to define in order for an electric aircraft to be qualified to ensure that it is safe to fly? So these are the responsibility of airworthiness teams to define the process that the team has to follow, because the aviation, in the other applications, right, non-aerospace application, we design the product and then we go to the certification. We get a certification based on the UL or the CE or DNVL for the ABS, that's for the marine application. So we take our product, go to the certification authority or qualification authority to tell that, okay, you qualify the product based on your standard requirements, and then they qualify and they certify, okay, this product is qualified according to the standard like CE or DNVGL or ABS and so on. But when it comes to the aviation, aircraft products, before we design the product, we have to come up with the planning process. So how I'm going to develop this product. So what are these what are the steps I'm going to follow? How I'm going to ensure that each and every code that goes inside the product is going to be verified if it is the safety critical. So there's a process that they have to follow, and the planning process that they have to follow. And then before they start developing, they have to get the authorities to look at the planning process to get a confirmation from the authority that, okay, this is the process is robust, it's fail-proof, and then the authority approve for them to go and develop the product, and then they go and certify or qualify the product. So this is the tedious. So it's not that even if you want developing the product, developing the energy efficient equipment is easy. Maybe you can do some trick to make it more energy efficient. But if it is not safety critical, if it is not, it is difficult to verify the product according to the safety requirements. It may not be successful. It may not be certified by authorities to fly. So these are the challenges that they have to comply to the standards. They have to comply to the regulations that authorities put forth. So that's a challenge that they have. And currently, it's not very clear because authorities and the OEMs are working together to define these standards, but it's not everything is being readily available for the OEMs to design and build the products, the propulsion product like motor or power converter or battery system that will be 100% qualified to fly, because there may be still the gaps that to qualify, but still industries are working on it. They have their own product to demonstrate the customer that okay, they have capability to design and develop. Yeah, so again, if you use the, for example, to make the things the smaller, right? The one way of achieving that in the electrical engineering approach is that we increase the voltage to reduce the cable size, and the other approach is that increase the frequency, right? So if you increase the frequency, increase the voltage, that can be done. So that will be a common approach being taken to reduce the size of the power converter or the electrical machine. But the challenge is that when you do that at a high voltage, high altitude, the chances for the discharge or the partial discharge or corona effect is very high. So how we are going to mitigate that? So these are some of the things need to be addressed. Okay, it's not been fully understood how this the partial discharge or corona discharge that would happen on the high voltage DC bus or a high voltage the high power density equipment, which we have increased the frequency. Again, the increasing the switching frequency that leads to the noise, right? How we can contain the noise, because aviation, the navigation equipments are sensitive to the noise. How we can contain that? So these are all the lot of challenges that the engineers working together to see how we can solve that to make the electric aircraft is kind of is certifiable and can bring it to the use for the commercial purpose. Okay, so with that, yeah, I finished my the lecture. This presentation. So if you have any question, please feel to put it in the chat or feel free to ask.
Dear participants, hello. Sir, in chat, some questions came. You please check.
Okay. All right. Okay, look at the chat. That's okay. Okay. What metrics or benchmark are used to determine if an organization or country is on track for net zero? So as I mentioned, that these are the 43 or the indicators that have been collectively put together by the so yeah, these are the something they put by the WRI. So these are the indicators that are being used to benchmark the progress. Yeah. Okay, so again, I think this question is a bit tricky. What metrics or benchmark are used to determine if an organization or country is on track for net zero? So actually, this is the country they use. As I mentioned, they have the policies, and then they track. I think, yeah. So they have the policy. It says that okay, by for example, I can talk about the Singapore. Okay, the Singapore set a target saying that they have a hovercraft. They call it as a hovercraft. Hovercraft is a small vessels, a small kind of vessel or boat that goes around Singapore, because Singapore is one of the busiest the harbor in Singapore in the world. So it serves many large ships. Okay, so they have about 1,500 small boats and the medium boats. So that's the larger vessels. So this currently being operated with the diesel or petrol. So they set the target saying that okay, by 2030, all the new harbor craft, that's the small boats that will be launched, are coming and entering into the Singapore. Um, is entering into the Singapore waters, should be complied to the net zero, which means that it should be either fully electric or it should be the using the fuel which is a carbon neutral. So that's the kind of the metric, a target that they set. So this is, so they track how well they are doing it. So that's kind of the kind of sort of metrics they use in order to track whether they are on the achieving the net zero target. And for the companies, again, so some of the companies, like the companies that I worked before, they say that, okay, by 2030, the emission that comes from the factory will be reduced by 50%. So that's a kind of what they said they want pro target, and then they have their own metrics to track whether they are achieving the target or not. So these kind of the different the milestones that they set, and they track the progress. Okay, so any other question?
Any other question, please? Sir, I think there is no question.
No question. Okay.
Okay. Thank you, sir.
Okay. Yeah. Thanks everyone for your participation. I hope this was the useful presentation. Okay. So if you have any question or anything, please feel free to mail me or approach me. I am available in the LinkedIn, or you can find me my contact details, or you can email me through the Singapore Institute of Technology website as well. Okay. Okay. Thanks everyone. Good night.
Okay, sir. Good night. Thank you, sir. Thank you.
Bye bye.
Bye, sir.
Bye.